the fuel vessels training, which is taking place as part of the on the MoS Way Network. And within this week, we will try to understand how the use of LNG as fuel is affecting the design of ships. So this is what we are going to see. First of all, let us see the whole framework. This is a module which is co-funded by the European Union, by the European Commission, under the 10T, what used to be a 10T, and now it's INEA. The 10T was for the Trans-European Transport Networks, and the purpose of these networks was to create interfaces, interoperability, continuity of services, and finance transport infrastructure projects. Under this framework, we had the Marco Polo program, which was one of the programs which NT was, let's say, organizing. And the Marco Polo program ran from 2007 to 2013. The one which is, let's say, is covering the action which you are going to participate in. And the purpose of it was to alleviate the congestion and pollution and promote greener modes of transport. There were more than 500 companies which have been approached using this program since 2003. And there were 5 categories of projects under the Marco Polo program. The main category was designed to switch to other means of transport, such as rail or sea from the road transport, because, let's say, we know that there is a lot of congestion in the roads using our cars and trucks, and these are emitting a lot of, let's say, harmful gases in the atmosphere. You need a lot of construction facilities and infrastructure in order to host the increased number of cars. And in that respect, the Marco Polo tried to move from the roads, cargo, and passengers to other modes such as rail and sea transport. The other 4 categories include catalytic action that promote motorways of the sea between major ports, actions to avoid traffic, which reduce the transport volumes, and common learning actions. This course is part of these common learning actions, which are promoting knowledge for the motorways of the sea. And there were also opportunities for co-funding by the European Investment Bank. So if there was an action that required increased funding, there was, let's say, an option to involve the European Investment Bank. So the motorways of the sea, as you will notice, the whole action is training for the motorways of the sea. What is the motorways of the sea? The aim for the motorways of the sea program is to extend existing and introduce new intermodal maritime supply chains in Europe and transfer freight transport from road to sea. The necessities were the more efficient than road transport, sea transportation. So we can, let's say, the emissions we have and the fuel burn per cargo ton is much less. We have economies of scale with sea transport, and that's what we try to use here. And there is greater sustainability with the motorways of the sea. The results would be excuse me. The reduction of road congestion and environmental impact on freight transport, and the improvement in access to European markets. The sea areas which have been selected for the motorways of the sea, you see here, this is the European continent, and you can see the various motorways here. We have areas in Baltic, in south and west and south and east European seas, and western Europe seas. You see here that the priority axis number 21, which is shown here, connecting the various places around Europe. So, in that framework, we come to our project, which is on the MoS Way Network. And what it is, there is this background that we have upcoming regulations which are seeking to reduce the CO2 emissions. We need to reduce the footprint of the CO2 emissions from the shipping industry, and this will lead ship owners to examine alternative energy sources and new technologies. In that respect, we believe that LNG is a solution, as it is very clean energy, and this low price was when we were, let's say, there was a significant gain in price when we made the proposal. Things have changed since because of the collapse of the fuel oil price. Let's say the oil became much cheaper. So there is still some gains. There are some gains still if you decide to use LNG, but the price difference is not that much. And we will see all these and how the market is changing and why the ship owner will decide to invest in LNG in the coming days. And the other thing is that we have high safety standards in this industry. When you apply LNG, LNG is not something new for the shipping, but of course we have to understand the risks and the opportunities better. So, in that respect, there is a clear need for training and capacities building, and there is interest from the sector stakeholders. We have the ship owners who will decide to invest in LNG fuel ships, so using LNG as the main fuel for the ships. And we have also port authorities and port managers who would like to invest in building infrastructure for bunkering those LNG fuel ships. So we need to have understanding from both sides of the key, so there will be some synergies and both sides will understand what's at stake. So the objectives of the project is to promote the use of LNG as a cheap and clean fuel for the shipping industry, aiming to reduce the transport costs, meet the tight emission limits, and we will see that although the price may go up and down, the emission is the main strong point of LNG, and we will understand why. The understanding and the appreciation of the pros and cons of LNG use as a marine fuel, and the development of a new culture in all the actors on board and on shore, as I said before, to understand their role for the safe operation of LNG fuel ships. Finally, to bridge the different perspective that the crew on board and the port have, creating a common understanding. The partners in this project are 8. Our university, the University of Strathclyde, is the leading partner, the coordinator, and then we have the City of Glasgow College, the University of Genoa, Circle, which is a company, an IT company. We have the La Spezia Port, the World Maritime University in IMO, the Ocean Finance, which is a finance specialized company in Greece, and the EPE, which is another major stakeholder in Greece, in Piraeus. The partners will run different modules and will collaborate in different modules. We will try to invite speakers and lecturers from the industry in order to educate our students and provide them with the state of the art. You will see in the next few days some of the most prestigious companies and experts coming in and presenting their work and their research here in order to understand what's the state of the art for the LNG and how it can be used on board ships. We have 5 modules. This is the first one, and we have another 4. The second one will be on the safety of LNG handling on plant, bunkering station, and on board ships, and this will take place this September, and it will be organized by the World Maritime University. Today, you are in a classroom, and students from the World Maritime University, UNITE, and other professionals from around Europe, they are following us from distance, and they are distance, they cannot see because you are behind the camera. Sorry. But we will take pictures of all of you. And we will upload them because there is a site for that. So today you are in the classroom, and they are as distance learning students. In the next module, you can participate. We will organize a classroom here. You can follow this, having the presentation, having let's say all the material, and you will be the distance learning students for the World Maritime University. The idea is that we are going to have a flexible learning modules where the students do not have to go from one place to the other in order to follow the modules. Everything will be recorded. It will be all we are presenting here will be uploaded later on, and with the slides it will be available to you so you can revisit what we have said and you can use this material. Yeah?
How does it work for us? Because we officially end the MSc on the 28th of August. So
it has nothing to do with the rest of your studies. It's not part of your studies here. You are doing this individually, and we, as you will see, I will mention later on, we are working in order to take the accreditation from the IMARES, and you will receive CPD points, continuous professional development points from the IMARES. So it has nothing to do with the other studies. There are students in other universities, but this is totally independent. Okay? The thing is that this is an action which is co-funded by the European Commission, and that's why there are no fees. We would like your participation and your feedback, because this is a pilot action. We would like to improve this. Your feedback in order to, let's say, judge how this was delivered, if let's say, the knowledge you received was sufficient for this topic, will be something that will help us develop these modules further on, and this will be a product which, let's say, we will have a platform which will offer this CBD courses in the future. Okay, so the next one is the LNG and ballast management training on liquid cargo simulation, and this will also will take place at the City of Glasgow College, which is very close here. The same module 4, the maneuvering of an LNG driven vessel, the special conditions and operations, and finally the propulsion and the power generation training of LNG driven vessel. The date will be confirmed later on this year. Okay, all the actions will have to be completed by the December 2015 this year, and we have a very large conference, international conference, which will focus on the training for the LNG fuel ships and the vocational education requirements to do so, which will be held in the TIC, in the Technology and Innovation Center, which was officially opened by the Queen last week. And there we will have guests and speakers from all over Europe. And you are welcome to participate. So, the module 1 is on LNG fuel ships and the design training, which you need to understand. The contents of my presentation here, let's say, and the other speakers who will participate in this, will cover the background environmental regulations, the shipping industry overview, and why someone in this current situation will decide to change from heavy fuel oil to LNG, the compliance strategies of owners with the regulations, the LNG supply chain, the design of LNG fuel ships, case studies of existing vessels powered by LNG, the standards and guidelines for natural gas fuel ship projects. So, what we will try to achieve here is to realize for you as students the current situation of the shipping industry. So if someone asks you for your opinion later on, you will have all the background information in order to make up your mind. To familiarize with the new environmental measures, regulations, which have been adopted in IMO. Introduce the alternative solutions, approach to LNG ship logistics, understand the main principles in design of LNG fuel vessels, and observe the basic alternations in contrast to conventional vessels. So what is the difference? Okay. Then finally, deepen the operation of alternative parts of LNG fueled vessels. This is the program for the next 5 today and the rest of the rest 4 days. Today I will cover the first part here for the introduction to the course, the environmental regulations of shipping industry. Then we will see the compliance strategies of owners with the regulations. And this afternoon, my colleague Leonidas Ketsinas will present the LNG civil logistics, which he is studying for the last 3 years, okay, or so. So next, we will have tomorrow presentations, which will be, we were planning to have these presenters on Tuesday from Greece. They were supposed to fly, but due to the problems we had, probably you have heard about the Greek crisis, they could not make it. So they will give us their lectures from using the same platform, the Spontanea, which we will see later on. And they will present from Athens. They will give the presentations to us in this class. Okay, so you will have also the experience of how it is to be a distant learning student. And we have two speakers, one from Ocean Finance and another one from EPE. They will cover the decision support tools for alternative fuels and the initialization of an LNG retrofit design of a cruise ferry, the challenges ahead and lessons learned so far. This is a design office. This is the phase company based in Greece. They have a lot of experience with the use of LNG, and they are participating in another very large European project, Poseidon Med, which is studying the conversion of a large part of the Mediterranean fleet, passenger RoPax fleet, into the use of LNG in order to reduce the cost and reduce the emissions. We will see why later on. Then on Wednesday, we have one of the most prestigious companies working and the most experienced companies working in the LNG. The GTT, which is, they are producing LNG tanks. They are one, let's say, one of the leading companies in the world right now. They were kind enough to visit us in order to present the latest developments in the tanks, in the technology. And on Wednesday afternoon, I will make a presentation about case studies of various new buildings and retrofit vessels. And Mr. Christinas is going to present a feasibility study of a refueling station for vessels using LNG as fuel. So we will see both parts, the vessel and the port. Then on Thursday, we have a presentation by our colleague here, Dr. Theodokatos, who is expert on LNG engines. So we are going to hear the experts on an expert on marine engines and the impact the use of LNG has to the design and the operation of the engine itself. Then this afternoon, initially we had a designer, a well-known designer for LNG vessels from BMT Titron. Unfortunately, we had to move his presentation on Friday, and we moved Dr. Kokarakis' presentation on Thursday afternoon. Dr. Kokarakis is an expert. He's a vice president of BV Classification Society Bureau Veritas in Piraeus. He has a very long experience on design and plan approval of ships, and he's going to present us the classification point of view, the Classification Society point of view for the design of LNG fuel ships. Then we will have on Friday the presentation from BMT Titron, and on Friday afternoon we are going to have a discussion. We would like to collect your feedback about the course and whether this was what you expected. And we are going to use this feedback in order to improve the module further on. Then we will have the assessment, because we need to have an assessment in order to provide you with the CBT. It's part of the let's say accreditation process. We need some exams. This will be a multiple choice test based on the information you have collected over this week. So, the IT tools for local students, we have the in-classroom presentations and any tutorial we may have. For distant learning students, we have the use of Spontanea for real-time participation to the courses. And this is, you can use this in Microsoft, Mac, and Android platforms. All the lectures will be recorded and uploaded for future use by the registered students, which includes you. The local students, as we said, will have the presentations. For the distant learning students, they should go to this link here in order to download the tool, which you can use. They can use in order to see the presentations in real time. They should use session ID 753 times O. All lectures will be recorded and uploaded, as we said. And if you have any problems, I would appreciate if you could forward them to my colleague Leonidas Christinas in order to collect them, and we can sort any problems out. Let me see if we have anything from the. Yep, we are okay. This, yep. Someone has it. Mic. Okay. Okay, so for the distant learners, any problems to report? Anything? Okay, so we move on. Excellent. So let's start why we are here. What is design? For those of you who are naval architects, the question is very simple. The answer is very simple. So I'm going to provide a very quick overview of the design for those who are not engineers, because we have also students who are following this who do not have a naval architecture background. So, what is design? There are different ways of defining design. You may say that design is the visualization and depiction of form, something we would like to show. You may use the definition that it's a mental process which must intervene between the conception of a specific engineering intention and the issue of drawings to the workshop. That's more material, let's say, process oriented. It is the optimum solution to the sum of the true needs of a particular set of circumstances. So we start with the need and we design a solution for that, which should be optimal because otherwise it's a failure. It's a creative, iterative process serving a bounded objective. So this is more artistic definition. Or you can say that engineering design is the use of scientific principles, technical information, and imagination in the definition of mechanical structure, machine, or system to perform pre-specified functions with the maximum economy and efficiency. Okay? So these are examples of different designs. You may think of the designing the part of the vessel, so the engine room. You may think the exterior design, the aesthetics of a yacht, or you may consider the design of the interior of such a yacht when you like the best experience from for the owner. Okay? So we have, as designers, we are using the design spiral, which depicts the iterations we have to do because we have a very complex problem. We have many different constraints, many different objectives which we need to meet, and we try to optimize our objectives and satisfy our constraints. And in that process, we start with the mission, or as we say, the owner's requirements, and we enter this loop of defining the vessel, trying to make sure that everything is according to our expectations and the owner's expectations and the rules and the regulations, and we comply with the rules and regulations that apply to this specific design. And we do this several times because we have one solution, then this feasible solution we try to improve it further on, and this is the process where we gain more knowledge until we find the optimum solution, which is somewhere at the center, and we meet our goal. This has been proposed by Taggart back in the 1980s. It's even there have been also proposals by others even before that date, but this actually visualizes the process we as naval architects are doing. So, on the other hand, if we try to see someone else's perspective, and in this case, because we are talking about changing the way the vessel operates, we need to see the other major shareholder in this game, which is the owner. So, whereas as designers we see a bottom-up approach, so as sea builders here we see that there is a hull form, there is a machinery, a propeller, and a steel structure which is carrying all these. The owner will usually have a top-down approach. So it will be like the bird flying above the vessel, seeing the payload capacity, the building cost, the bunker consumption, and the crew cost. And believe me, all these are affected from the change we are about to see with the use of LNG. Okay, so we have to have a spherical view. We need to see these things from the point of view of the owner also. Ship types. When we talk about ships, there are so many different kinds of ships. And this is just a few examples. We have the conventional, bulky bulk carriers or tankers, the heavy, let's say the heavyweight vessels with a large blow coefficient, as we say in naval architecture. We have the planning crafts and the passenger ships, which are usually they require higher speeds. Sometimes when the bunker price was lower, they were used to go close to 40 knots because the fuel oil was low and there was a requirement for very high-speed transportation, and the passengers were willing to pay the extra cost in order to reduce the time spent on board. We have the advanced marine vehicles, such as the acroplanes, which are, let's say, close to being airplanes, only being more, let's say, efficient and less more fuel saving. We have submarines, which are moving under the water. We have other vessels, pentamarans or catamarans, which are light. They have to be light because otherwise the additional wetted surface they have will be a penalty for them. So they need to be sufficiently light in order to reduce the drafts in this semi-swath version, and the draft also end of the planning, let's say, mode for this one. We have trimarans or surface effect ships. So what kind of vessels are we considering? According to the examples we have right now from actual vessels where LNG has been studied for use, only, let's say, displacement type vessels are good for use for the LNG. Okay, because we will see that the tanks they require a lot of weight, additional weight to the structure. There are also other considerations, the strength requirements in order to place the very heavy tanks on board the vessel. So most of the designs that have been presented up to now were for, let's say, bulk carriers, container ships, especially container ships, also support vessels and passenger ships, but not high-speed vessels. Okay. So, yeah, I. So, who will ask for this change? As we said, the design spiral starts with the statement from the owner, what the owner would like to achieve. Most of the forward-looking owners are basing their requirements on a careful analysis of their needs. Who is the cargo owner, the charterer who will charter the vessel, and a market research. What is out there, what the options are, how I can be more competitive. These requirements can be categorized into performance requirements, the amount and the type of cargo, the speed, which is the optimal speed for the operation we would like to do, the range, what's the distance we need to cover with the existing capacity of fuel on board, the availability, meaning the maintenance policy and the reliability, and other factors, the utility, whether we need some flexibility or the ability to change the roles, the loading, discharging of cargo, and so on. And finally, cost. And when we talk about cost, we mean we include the initial cost, the procurement cost, the running cost, and the maintenance cost. Okay. mainly, and whatever cost other is included in general. But these are the ones who will affect the ship owner who will decide to invest for an LNG fuel vessel. So the design of an LNG fuel ship will come as a requirement from the owner. And it is going to have a significant impact to the design because it's going to alter the propulsion systems. You see here in this picture, you need the LNG tanks, you need the fuel, you need to take into consideration all these things. It's going to change the general arrangement. This space used to be empty now, or this was in this case, this is a container ship. So at this space, it was carrying some containers. It's going to reduce the carrying capacity of the vessel for the same principal dimensions. It's going to affect the structure because we will see these tanks are very heavy. So you need to reinforce the aft section of the vessel. And this is just an example in order to hold this additional weight. And you need to make sure that the structure here will have sufficient strength in order to reduce also vibrations and things like that, because you have also the propeller underneath. So you need to make sure that it will be strengthened properly. The stability, you are going to put a lot of weight above the deck in this case, so this will affect your stability. It's going to rise the vertical center of gravity, and this will reduce your initial stability. The endurance, you will probably not. You'll have to do some compromises. You have to rethink the distance you have to cover using the LNG, because the amount of LNG you are going to carry per cubic meter is very expensive in order to invest to larger tanks. So you have to find the best solution. How, let's say, what's the distance between the refueling points you need in order to optimize the size of the tanks. When you had the heavy fuel oil tanks, these were built in the vessel, so there were spaces within the hull which you use them just, let's say, making them oil tight, and they were ready to be used. Now you have to put some more equipment on board, and this actually will affect your carrying capacity, because you have a limiting draft. You cannot, let's say, violate that. For the same principal dimensions, you are going to have less carrying capacity compared to a conventional vessel. The naval architect will have to adopt the design to the owner's requirements and comply with all the applicable rules and regulations. And we are going to see which are these rules and regulations you have to comply with. Any questions up to now? Okay, so let me check also. Sorry. Okay. Fine. So I continue. Which is the reason we are discussing even about LNG? This is the reason. The new environmental regulations. So we have to understand why the LNG is even considered. why we have to do all these changes to the conventional ships we have out there. So, uh, we have the emissions from the shipping industry, and we know that we have 5 different categories of emissions. We have the SOx emissions, the particulate matter emissions, the NOx emissions, the CO2 emissions, and we have waste, which are solid and liquid wastes. Let me see if this works. Can you hear that?
No.
This is why, for instance, NOx are a problem. This is one of the solutions. Okay. So we will see more about this solution, but let's see. This is the stack, the final of a vessel. This looks like a cruise vessel. So you see, out of that we have CO2, NOx, SOx, and particles. We know, according to the United Nations and the IMO studies, that an important part of the global anthropogenic emissions comes, let's say, from whatever we are doing in this planet. And back in 2007, the second IMO greenhouse gas report found that 15% of the NOx for, let's say, the emissions produced by people belong to the international shipping. 9.5 and 9.4 of SOx, sorry, and 2.7 of the CO2. The third one, which was published last year, due to the financial crisis in 2008 and the slowdown of the world economy and the slow steaming of most of the vessels for, let's say, during the last 7 years, found out that we had the CO2 contribution of the international shipping, because we have also national shipping, which is not included here. The international shipping is 2.2%, and the NOx and SOx are 13 and 12 respectively. So we see that for the SOx, we have a lot of contributions from ships, and also for the NOx, and we need to do something, and that's what the new regulations are trying to establish. There is also the trend, which is more alerting, that since 1990 and 2007, the emissions of key pollutants, which are NOx, SOx, and PMs, and the greenhouse gases, mainly CO2, increased almost doubled, let's say, from almost 600 million tons. They reached close to 1,100 million tons in shipping industry. So we have to do something. This is another very interesting map. It says that in 2008, according to a study, the emissions of NOx, SOx, and particle matter and CO2 in the Mediterranean Sea was established at 2 million, 1.45, 0.157, and 87.6 million tons. And what this study found was that this was 50% higher total emissions compared to other European seas, and this was mainly because of due to the traffic and the older fleet. So this was the reason why a lot of activities were taken and were funded by the European Commission in order to reduce the emissions in the Mediterranean Sea. So the air pollution in the European agenda was introduced after it was first introduced in the IMO, the International Maritime Organization. The air pollution is covered under the MARPOL, which is the Marine Pollution Act. And it's this is for the prevention, the Convention for the Prevention of Pollution from Ships. It was the first one was established in '73, and the second one, the amendment in '78, and there are a number of articles which have been, let's say, refined and introduced later. The air pollution is regulated by the Annex 6, which covers the regulations for the prevention of air pollution from ships, and this is from 2005. These are more stringent measures adopted by the IMO and in relation to SOx and NOx, and they are introduced with the revised Annex 6 to MARPOL. In the European Union, we have a white paper on transport, which sets a target to reduce the greenhouse emissions at least 40% by 2015, compared to 2005, and in absolute terms for the maritime sector. The shipping industry should also contribute to the reduction of local and global emissions. This is the reason why we are thinking about LNG. The European legislation is aligned with the IMO requirements, with the directive 2012/13 of the European Union, and this is requires stricter sulfur limits for marine fuels. The limit was 1% until the end of 2014 and 0.1% from the January of 2015. We will see again these levels with the chart. And in marine areas outside SECAs, we had 2.5% by June 18th, 2014. And initially we have 0.5 for the 1st of January 2020, but this will be re-examined at the MAPC, the convention about the environment, which is part of MARPOL's, let's say, renewal, which will take place in 2018, as it will assess the availability of the required fuel oil, and if this is decided by the experts, instead of 2020, we may extend this lower limit outside SECA areas to 2025. But we have to wait until 2018 to revisit this decision. In this map, you can see the SECA areas. This is the SECA area which is actually affecting the UK, which this covers the North Sea and the Baltic Sea area. And you see that here we have the east coast of UK is affected by the SECA area which exists. And in this area, the vessels which operate have to comply with the new regulations. This has already affected the shipping in the North Sea, and affected Scotland in particular, because the FDS made a study of how to comply with its ships which transport goods from the continent to Scotland directly to Rosyth, and we found out that it was not cost effective for them to invest in upgrading their vessels. And I think that a few months ago they actually made an announcement that they are going to stop this route. I have to check it again, but this is my understanding according to what I read in the news. So the thing is, we will see why this might be the decision of a ship owner if the shipping company has a vessel which has passed its mid-age. It may not pay back the investment required in order to upgrade to the new SECA area requirements. So this is the chart where you can have a clear picture. We have the inside ECA area SOx emissions. That's why we have SECA. And if we had NOx limits, this would be NECA. And if it's SOx NOx, it will be a general NECA emission control area. So these are the key dates: 2010, 2015. From the early this year, we have these limits, the low limits, and this is the outside of ECA area. We said that here we have to see the fuel availability in 2020, and this might move back to 2025. So these are the sulfur limits according to Annex 6 of MARPOL. So the IMO and the MARPOL have not only requested the change of emissions, they have set they created a number of tools which can be used by the shipping companies in order to